Dear students, this is our sixth class on the chapter Laplace transform, and in this class we will solve some problems on inverse Laplace transform. So let us start. First, the first problem is here. Find the Laplace inverse transform of the function p by p square plus a square into p square plus b square, where a and b are constants. So in this case, this is the Laplace inverse transform. So the given function, let us we consider the given function fp, that is equal to p by p square plus a square, and then p square plus b square, and we are here to find out the Laplace inverse transform of this function. So now fp can be written as, that is equal to, you can write this term can be written as, this term can be written as 1 by b square minus a square by p by p square plus a square minus p by p square plus b square, that b not is equal to a, because the reason is here. You can write this term as, see here, because this term is equal to calculated here 1 by b square plus a square, then this p by p square plus a square minus p by p square plus b square, that is equal to 1 by p square minus a square. Then the here the LCM, that is here, LCF is there, LCF is here, p square plus a square, then p square plus b square. The first term is p cube, then plus b square p, then minus p cube from here, from this term, minus a p square. And just simplify this. The numerator will provide you p into p square minus a square, and this 1 by b square minus a square is here, and this p square plus a square and p square plus b square is there. So that is equal to p by p square plus a square, and then p square plus b square. So this p by p square plus a square into p square plus b square can be written in this way, in this fashion. So the inverse Laplace transform of this Zp is given by L inverse p by p square plus a square into p square plus b square, that is equal to 1 by b square minus a square, because this is a constant. Then N inverse p by p square plus a square minus p by p square plus b square, that is equal to 1 by b square minus a square, L inverse p by p square plus a square, then minus L inverse p by p square plus b square. And from there you can write this, because this is nothing but the L inverse Laplace transform of p by p square plus a square is nothing but cos ax, and L inverse p by p square plus b square is nothing but cos bx. So this, the Laplace inverse transform of this function, that is equal to 1 by b square minus a square, this b square minus a square is there, cos ax minus cos bx, because we know that L inverse p by p square plus m square is equal to cos mx. Already we know this. Now second one is there, find the inverse Laplace transform of the following function, that is fp is equal to p plus 2 by p square minus 4p plus 13. So the inverse Laplace transform, so let us consider that the function, given function fp is here, that is this given by this. So the Laplace inverse transform of this function fp is equal to L inverse p plus 2 by p square minus 4p, p square minus 4p plus 13, that is equal to L inverse p plus 2, and you can write this term as p square minus 4p plus then 4 then 9. That means p minus 4, p minus 2 whole square then plus 3 square. You can write this in this way. So that is equal to L inverse, and you also can write this p plus 2 as p plus 4 minus 2. So this basically will give you the p plus 2. This will essentially give you p plus 2 by p minus 2 whole square plus 3 square. That is equal to L inverse. Then just separate this, p minus 2 by p minus 2 whole square plus 3 square. Then plus this 4 will be there, and I am writing 4 by 3 L inverse, so 3 will be there also. 3 by p minus 2 whole square plus 3 square. So you can write the second term, that means 4 by p minus 2 whole square plus 3 square as 4 by 3, then L inverse 3 by p minus 2 whole square plus 3 square. That is equal to, therefore L inverse p plus 2 by p square minus 4p plus 13, that is equal to, you know that only p by p square plus 3 square, that would be the inverse Laplace transform of only p by p square plus 3 square is cos 3t. 3t or 3x, you can also write 3x, whatever may be the function. So cos 3t, okay, that is cos 3t. But since p minus 2 here, p minus 2, so in this case e to the power 2t will be there, because we know that since L inverse p minus a by p minus a whole square plus b square is equal to e to the power at cos bt. Okay, you know this, and therefore this will provide you e to the power 2t cos 3t. Then plus 4 by 3 is here, and 3 by p minus 2 whole square, because only 3 by p square plus t square would be the inverse Laplace transform of 3 by p square plus t square is the inverse will give you the result sin 3t. Since p minus 2 is here, so it would be e to the 2t. So 4 by 3 to the 2t sin 3t, because the result is the real inverse b by p minus a square plus b square, that is equal to e to the power at sin bt. Okay, here is equal to 3 and b is equal to 2. So finally we obtain e to the 2t cos 3t plus 4 by 3 to the power 2t sin 3t. So now the next one is there. Find the Laplace transform, inverse transform of p minus pi by p square minus 3p plus 2. So just let us consider here this p minus 5 by p square minus 3p plus 2, that is just factorized here. So that is equal to, you can write p minus 5 and this can be written as p minus 1 and p minus 2. Okay, that is equal to, that can also be written in the form a by p minus 1 then plus b by p minus 2. You can write this in this way, and simplify this, then it would give you a into p minus 2 plus b into p minus 1. Just write this in this way, where a and b, we are to find out the value of a and b. So this will provide you a into p minus 2 plus b into p minus 1 by p minus 1 into p minus 2. So now just compare both sides of this equation. We'll have this p minus 5 is equal to a into p minus 2 plus b into p minus 1. So now in this expression, first just put p is equal to, or consider p is equal to 1. Then if you use p is equal to 1 in this relation, then then what will have, you will have the form here p, since p is equal to 1, so 1 minus 5, that is equal to a into 1 minus 2, because this term will give you 0 result. So that from here you obtain a is equal to 4, a is equal to 4, and for p is equal to 2, for p is equal to, this term will give you null result. So p minus 2, that is here, that means 2 minus p, sorry, 2 minus p, that is equal to b into 2 minus 1, or b is equal to minus 3 from here. So we have succeeded to find out the value of a, that is equal to 4, and b, that is equal to minus 3, and just substitute these values in this expression. So p minus 5 by p minus 1 and p minus 2, that is equal to 4 by p minus 1, then minus 3 by p minus 2. So Laplace inverse transform of this, that is p minus 5 by p square minus 3p plus 2, that is equal to Laplace inverse transform of this 4 is taken here, since a is equal to 4, then 1 by p minus 1 from here, and then minus, since b is minus 3, so minus 3 is here, L inverse 1 by p minus 2. So that is equal to, you know that the Laplace inverse transform of e to the power x is 1 by e to the power ax is equal to 1 by p minus a. So in the first case a is equal to 1, and the second case a is equal to 2. So the Laplace inverse transform of this function is equal to this 4, then e to the power x, minus this 3 is here, then e to the power 2x. So this is the inverse Laplace transform of this function. Now determine the Laplace inverse transform of log p square plus p square by p square plus 4. So now let that fp is equal to log p square plus by p square plus 4, and you can write this in this way, log p square minus log p square plus 4. You can write this. Okay, so then just differentiate this fp with respect to p. So f prime p, that is equal to, from here you can write that the differentiation of this will give you 1 by p square, then the differentiation of 2p, that means 2p by p square, differentiation of p square, first log p square, that means 1 by p square, then the differentiation of p square will give you 2p, then minus, and this will provide you first p square plus 4, then this will give you 2p. So from here, from the first one 2 by p, and the second one 2p by p square plus 4. So the Laplace inverse transform of f prime p, that is equal to, you can write this as that is equal to L inverse Laplace inverse transform of 2 by p, then minus Laplace inverse transform of 2p by p square plus 4. So that will give you 2, this 2 is taken here, and you know that Laplace inverse transform of 1 by p is equal to 1, that is here, and for the second term 2 is here, and Laplace inverse transform of p by p square plus 4, that is equal to cos 2x, because we know that Laplace inverse transform of p by p square plus a square is equal to cos x. In this case, your a is equal to 2. So it is not very difficult to understand. So that is equal to 2 into 1 minus cos 2x. So now 2 into minus 1 minus cos 2x. Okay. Now we are find out the value of because you know that L inverse dn dx and fp, that is equal to minus 1 to the power n xn fp. So just writing this first here, because you know that in that case you know this formula or the property. We have discussed it. So L inverse, this is f prime p, that means dfp by dt. So in this case, the first order differentiation is taken, and that is equal to minus 1 to the n. N is in this case 1, so this will give you minus 1. Then xn, that means x is here because n is equal to 1 in this case. Then fx. Fx means fp, and fx means L inverse fp. Okay, this is cut. No problem is there. So just use this property L inverse dxn a by xn fp, that is equal to minus 1 to the power n xn fx. In our present case, your n is equal to 1, so minus 1 is here. Then is x to the power n, means x to the power 1, that means x is here, and then there should be fx, and you know that fx is nothing but L inverse fp. Okay, that is equal to 1 minus cos 2x. So from here L inverse fp, that is equal to this 2, and this will go into negative side, so negative minus 2 by this x, 1 minus cos x. So now fp is what? fp is here ln p square log p square plus p square by p square plus 4. So L inverse, just use here fp, the value of this, log p square by p square plus 4, that is equal to minus 2 by x, 1 minus cos 2x. So the inverse Laplace transform of the function, this function, is equal to this. Now the next one is here. Find the Laplace inverse transform of the following functions: 1 by p plus a whole cube, then p by p square minus a square whole square, then p by p square plus a square whole square. So first one is here, and you know that that you can write a dtp of 1 by p plus a, that is equal to, you can just compute this value, the differentiation of 1 by p with respect to p, that is equal to minus 1 by p plus a whole square. So and d2 by dp square is equal to now the second order derivative of this 1 by p plus a, which is to p, that is d2 by dp square, that is 1 by p plus a, that is equal to this minus is here. Then ddp, because you already obtained ddp of 1 by p plus a is equal to minus 1 by p plus a whole square. From there you can write this d2 by dp square 1 by p plus a, that is equal to this minus here, and then ddp 1 by this value p plus a square, just compute this value, and finally we obtain 2 by p plus a whole cube. Therefore Laplace inverse transform of 1 by p plus a whole cube, that is equal to, from here you can write that is equal to because you know that 2 by p plus a whole square whole cube, that is equal to d2 by dp square 1 by p plus a. So from here 1 by p plus a whole cube, that is equal to half d2 dp square 1 by p plus a. Okay, and therefore inverse Laplace transform of 1 by p plus a whole cube, that is equal to half, then L inverse d2 dp square 1 by p plus a. Now you know the relation that dn by dn into dpn dn by dpn 1 by p plus a, that is equal to minus 1 to the power n x to the power n fp. You know this relation, this property. In this case, n is equal to 2 over here. So this is equal to this. This will give you the inverse Laplace transform of this. Will give you actually the inverse Laplace transform of this. Here there should be inverse Laplace transform. Inverse Laplace transform of dn by dpn 1 by p plus a, that is equal to fp would be here. Fp, that is equal to minus 1 to the power n. Okay. Laplace inverse transform of dn dpn 1 by p plus a, that is equal to minus 1 to the power n x to the power n fp. Okay, so from this relation we have half, then minus 1 to the power 1 square, because in this case n is 2, then this x to the power n is equal, in this case 2, so x square, then L inverse 1 by p plus a. So that will give you that will give you half x square into, because you know that the inverse Laplace transform of e to the minus ax is equal to 1 by pa, because you know the inverse Laplace transform of 1 by p minus a is equal to e to the ax. So using this relation, the inverse Laplace transform of 1 by p plus a would be e to the minus ax. So finally you obtain that the inverse Laplace transform of 1 by p plus a whole cube, that is equal to half x square e to the power minus ax. The next one is here ddp of 1 by p square minus a square, that is equal to, just for the next case, the next problem is here. The next problem is what is the p by p square minus a square whole square. We are here first find out the value of ddp of 1 by p square minus a square, that is here, and then L inverse ddp of 1 by p square minus a square is equal to minus half, from here you can find out from here, minus half L inverse ddp of 1 by p square minus a square, and you know from here that that is equal to minus half, and using this relation actually you can write it is minus 1 then x then L inverse 1 by p square minus a square, just using this relation, and then it will give you half then x then 1 by a sine hyperbolic x, because you know that the value of this term is sine hyperbolic x, and this negative will give you positive sign. So this is equal to 1 by 2a x sine hyperbolic x. So the L inverse Laplace inverse transform of p by p square minus a square whole square, that is equal to 1 by 2a x sine hyperbolic x. Just all the steps are given here. You need to just compute this or calculate this in your own hands. So just you have to practice it. The next one, we are here to find out the value of ddp of 1 by p square plus a square, because here the term the function was p by p square plus a square whole square. So here just the same process is carried out here. First ddp of 1 by p square is find out here, and then the inverse Laplace transform of p by p square plus a square whole square from here is taken, that is equal to minus half, then L inverse ddp of 1 by p square plus a square, that is here, that is taken here. So using the same relation, that is this relation, using this relation, you will able to find that this will give you minus half first, this minus half is here, then x to the power 1, since in this case first order derivative is here, so minus x to the power 1, because the result is here, minus 1 to the power n, so n is here, so minus 1, then x to the power 1, then L inverse 1 by p square plus a square, and you know that the Laplace inverse transform of 1 by p square plus a square is sine ax. So finally you obtain minus 1 by 2a x sine ax. So the inverse Laplace transform of p by p square plus a square whole square, that is equal to minus 1 by 2a x sine ax. Next one is here, find out the inverse Laplace transform of 5 by p square plus 4p plus 10. So in here the Laplace transform of the given function is L inverse 5 by p square plus 4p plus 10. That is equal to L inverse 5 by, you can write this as p plus 2 whole square, because p square plus 4p plus 4 then plus 6. So that can be written as p plus 2 whole square then plus root 6 whole square. So that is equal to, you can write this as, this 5 is taken here and I am divided it by square root 6. Then L inverse, I am taking here another square root of 6. Then this will give you the essentially this one. So by p square p plus 2 whole square, then square root 6 whole square. That is equal to 5 by root 6 e to the minus 2x sine square root 6x. Why? Since because Laplace transform of sine ax is equal to a by p square plus a square. So in this case, see here a is root 6 and your a is in this case root 6, square root 6. Okay, but you also know that but by obeying this relation, Laplace transform e to the minus rx e sine ax, in this case according to first shifting property, this p should be replaced by minus r. That means in this case p should be replaced by p minus r, that is p plus r. So this will provide you a by p plus r whole square plus a square. So comparing this, in this case r is equal to your 2. Okay, r is equal to 2. So from there you can write that according to obeying this relation, from here you can write this 5 by square root 6 is here, and from here since in this case r is equal to your minus 2 actually. R is equal to minus r is equal to 2. So e to the minus rx, that means e to the minus 2x will be there, and then sine because in this case a is equal to your root square root 6, so square root 6x. So just this is why we obtain these from here. The reasons are here stated here. So therefore Laplace inverse transform of 5 by p square plus 4p plus 10, that is equal to 5 by root square root 6 e to the minus 2x sine 6x. Okay, now go to the next problem. The next problem is here. Find the inverse Laplace transform of 1 by p square plus 4p. Here the entire calculation is given here. Just you go through this, and reasons are also, the formula are also what kind of reasons are imposed in this problem, that are also stated here. Just you look this and go through this and compute it in one. I am not going to that calculations. And another one is here. Find the Laplace inverse transform of 1 by p plus 1 to the 4 plus p minus 3 by p minus 3 whole square plus 6. So here is the inverse Laplace transform of this function, that is there, and that can be written as L inverse 1 by p plus 1 to the 4 and then plus L inverse Laplace inverse transform of p minus 3, and you can write this as p minus 3 whole square plus root square root 6 whole square. Okay, and you also can write this as L inverse 1 by 3 factorial, then 3 factorial by p plus 1 to the 4, then plus L inverse, and from here p minus 3, then p minus 3 whole square plus root square root 6 square. And then from here you can write 1 by 6 because this 3 factorial is 1 by 6, L inverse 3 factorial by p plus 4, p plus 1 to the 4, then plus L inverse p minus 3 by p minus 3 whole square plus square root 6 square, and the result is here from here. And the reasons are also stated here, because first term is, you see here 3 factorial by p plus 1 to the 4. Go to here. You know that Laplace transform x to the power n is equal to n factorial by p to the power n plus 1. And in your case, see here, in this case, since 3 factorial n factorial by p to the power n plus 1, so here your n is actually 3. So that is here, n is equal to 3. So you know that this Laplace transform x to the power n is equal to n factorial p to the power n plus 1. Here n is equal to 3. That means from here you will have Laplace transform x to the power x cube, that is equal to 6 by p to the power 4. Okay. Now if Laplace transform e to the rx x cube is computed, that will give you, first you have to compute the Laplace transform of x cube, that is equal to 1 by 6 by p to the 4. And if e to the rx is taken as, then according to first shifting property, this p should be replaced by p minus r. So in this case r is your 1. In the present case r is your 1. So that p is equal to p plus 1 to the 4. So that actually nothing but e to the power. So this value will give you e to the minus x, then x cube. Okay. After that, the value of this, you see here the inverse Laplace transform of p by p square plus square root 6 square, that will give you cos square root 6x. And since in this case p minus 3 is there, so that will give you e to the 3x. Why? The reason is there. This reason is also stated here. L of cos x is equal to p by a square plus p square plus a square. Then L of e to the r cos ax is equal to, according to first shifting property, this p should be replaced by p minus r. So p minus r by p minus r whole square plus a square. Okay, this is the reason. And in this case your r is minus 3, so it will give you e to the 3x. Okay. Your r is equal to 3. Sorry, your r is equal to 3, so that will give you e to the 3x cos square 6x. Now find the Laplace transform of p by p square minus a square. A square whole square should be whole square. Laplace inverse transform of p by p square plus p square minus a square whole square. P square minus a square whole square. So we will find out the value of this function. That is, it should be p by p square minus a square whole square. So the Laplace inverse transform of p by p square minus a square whole square, that is here L inverse p by p square minus a square whole square. And here just find out the value of ddp of 1 by p square minus a square, that is minus 2p by p square minus a square. And from here, because you just use this method, actually you can find out, and here the calculations are here. So therefore, Al Laplace inverse transform of p by p square minus a square whole square, that is equal to, from here you can write minus half then L inverse d dp of 1 by p square minus a square, because d dp of p square minus a square is equal to this, and from here you can write p by p square minus a square whole square, that is equal to minus 1 by 2 d dp of 1 by p square minus a square. Just use we have calculated this value, calculated the value of p by p square minus a square, that is just substituted here. So minus half then L inverse d dp of 1 by p square minus a square, that is equal to, using the relation, because you know the relation of the property that L inverse dn dpn fp, that is equal to fp is the Laplace transform of the function, this is the fp actually, that is equal to minus 1 to the power n x to the power n fp. Fp is the Laplace transform of the function fx. So here minus, in this case the differentiation is first order, so minus 1 to the power 1, this half is here, minus half is here, then x to the power 1, then L inverse fp is here, fp is 1 by p square minus a square. So that is equal to this minus half is here, and this minus also here, so this will provide you a positive sign here. So plus, this is plus actually half x, then this is nothing but this will provide you the result 1 by a sin hyperbolic x, because the Laplace inverse transform of 1 by a sin hyperbolic x is equal to 1 by p square minus a square. This has been calculated. Okay, so finally we obtain this. So now the another problem is here, find the Laplace transform of p by 5 by 4p square plus 1, then 3 by p cube minus 3 by 2p. Here just I am here to find out the value of a Laplace inverse transform of this value 5 by this term 5 by 4p square plus 1, that can be written as L inverse 5 by 4 into p square plus 1 by 4. That can be written in this way. 4 is taken as common part term, that is this 5 and this 4 is taken outside the outside, that is 5 by 4. L inverse here half by p square plus half whole square, and since here half is taken, so 2 should be multiplied here. Okay, so we finally get 5 by 4 L inverse half p square plus half square with 2 is here. So this 2 and this 4 will give you 5 by 2, and here you know that Laplace transform of sin ax, that is a by p square plus a square. In this case your a is half. In this case your a is half. So that will give you, so L inverse Laplace inverse transform of this will give you sin half x, that is here x by 2, and further L inverse 3 by p cube, that is equal to 3 by 2, you can write this, then L inverse, then you can write this 2 by p square, p cube means p square plus 1, p to the power 2 plus 1, and this 2 can be raised to 2 factorial, and this has the similar form that Laplace transform of x to the power n, that is n factorial by p to the power n plus 1. Since it is 2 factorial, so in this case n is equal to 2. So if n is equal to 2, then this 3 by 2 is taken here, and that will give you x to the power n, that means x square. Okay, x square. And the last term is here, this 3 by p, 2p, that is L inverse 3 by 2p, that is 3 by 2 is taken here, L inverse 1 by p, 1 by p means x. Because you know that L inverse Laplace transform of 1 is equal to 1 by p. So that is here it should be 3 by 2 only. 1 by p, okay, 1 by p will give you only 1, because you know that Laplace transform of 1 is equal to 1 by p, so Laplace inverse transform of 1 by p will give you only 1, so this will give you 3 by 2, this x should not be there, you should correct it, 3 by 2. So L inverse of these terms will give you this result, but the last term is 3 by 2, okay, not x, 3 by 2. Now go to the next one. Find the inverse Laplace transform of the following functions fp, that is equal to p plus 3 by p square plus 4p plus 20. The given function is here, p is equal to p plus 3 by p square plus 4p plus 20, and that can be written as p plus 3 is here, p plus 2 whole square, then 4 square. You can write this as in this way. That is equal to p plus 2. You can write this p plus 2, then plus 1, and here if that the denominator is here p plus 2 whole square plus 4 square. That is equal to, you can write this as p plus 2 by p plus 2 whole square plus 4 square plus 1 by p plus 2 whole square plus 4 square. So the Laplace inverse transform of the ZP is equal to L inverse p plus 2 by p plus 2 whole square plus 4 square, then plus L inverse 1 by p plus 2 whole square plus 4 square, and since you know that L cos Ax, that is the Laplace transform of cos Ax is equal to p by p square plus a square, then and Laplace transform of e to the power minus Rx cos Ax, that is equal to, in this case using first shifting property, this p should be replaced by p minus of minus r, that is p plus r. So that is p plus r by p plus r whole square plus a square. So in this case, we compare these with this term, your r is 2, your r is 2, and a is your 4. A is your 4. So this term L inverse p plus 2 by p plus 2 whole square plus 4 square will give you the result, that is e to the power minus 2x cos 4x. E to the power minus 2x into cos 4x. This will give you. And also that is also written here. So L inverse this is equal to e to the minus 2x then cos 4x. And similarly the second term, that is this term L inverse 1 by p plus 2 whole square plus 4 square, that is equal to, because you know that this term actually this term that is, because you know that this will provide 1 by 4 sin 4x, and since in this case here 2 is here, so it will minus 2x. So L inverse 1 by p square plus a square is equal to, because the reason is here, L inverse 1 by p square plus a square is equal to 1 by a sin ax. This is the reason, this is the formula. So using this, in this case a is your 4. So following this relation, L inverse 1 by this will provide you 1 by 4 will, since 1 by a, so 1 by 4, then sin x, that means 4x, and also since p is replaced by p plus 2, so in this case just comparing to this, r is minus 2, so in this case e to the minus 2x will be, another term will be there. So finally we obtain p plus 3 L inverse p plus 3 by p square 4p plus 20, that is equal to e to the minus 2x cos 4x plus 1 by 4 sin 2x. So this is the result. And another one problem is here. So evaluate the integral 0 to infinity t e to the minus t sin t dt. So you know that the Laplace transform of the function t sin t, that is equal to minus 1 to the power n, then ddt of the Laplace transform of sin t. You know that, because you know that L Laplace transform of x sin a x fx, another function is fx taking. So x fx, that is equal to minus 1 to the power minus 1, if you know the general formula, that is Laplace transform of x to the power n fx, that is equal to minus 1 to the power n, then dn dpn fp is the Laplace transform of fx. So in this case sin t is the function fp. We have to find out the Laplace transform of sin t, and due to following that relation, you can write L of t sin t is equal to minus 1 to the power n, then ddp of Laplace transform of sin t, that is 1 by p square plus 1. So from here you can write, you obtain 2p by p plus 1 whole square. And furthermore also again Laplace transform of t sin t can be written as by following the relation, following the definition, that 0 to infinity e to the minus pt, then the function t sin t dt, because you know that Laplace transform of function fx, that is 0 to infinity e to the minus pt fx dx. So in this case the function is t sin t. So Laplace transform of t sin t, that is 0 to infinity e to the minus pt t sin dt, and that is equal to, you know, that is equal to 2p by because this value, this relation and this relation, just compare these two relations, and then sin L of sin t, that is equal to this integral, that is equal to, from here 2p by p plus 1 whole square. Now compare this term and this term. See here, in this case p, actually p is equal to 1, and so if you substitute p is equal to 1 in this relation, this will give you this, and the result is here 2 into 1, because in this case p should be replaced by 1. So 2 into 1 by 1 plus 1 whole square, that will give you 2 by here 4. Okay, So 0 to infinity t e to the minus t sin t dt is equal to half. So this integral is computed very easily using your Laplace transform. Okay, so this is the end of this class, and I will suggest you to calculate all the calculations in your own hand. Then everything will be clear to you.